Good day, everyone. My name is Lim Singing, and today I'll be presenting my study with the title of Predicting Employee-Persistent Work-Life Balance Using Machine Learning. So first of all, work-life balance is increasingly recognized as a crucial factor in employee well-being, satisfaction, and retention. It reflects how individuals manage their responsibility between their work and personal life. In this study, we use a data set of 5,000 employee records from Kaggle to explore whether machine learning can predict work-life balance. There are 6 supervised machine learning algorithms used in this study, which are logistic regression, random forest classifier, decision tree, k-nearest neighbor, native Bayes, and gradient boosting classifier. Although these models achieve high accuracy, but their performance on key metrics like precision, recall, and F1 score was much lower. I will explain it more shortly. So the modern workplace had made it harder for employees to maintain a healthy balance between work and personal life. This imbalance can lead to job dissatisfaction, stress, burnout, or even high turnover rate. With growing access to employee data, machine learning can translate this data to predictive insight that could guide human resource strategy. By developing accurate prediction models, organizations can take proactive steps to improve overall workplace satisfaction. Therefore, this study aims to evaluate machine learning algorithms to predict employee-persistent work-life balance in order to reduce attrition. Next, this project has 3 main goals. First is to propose the champion machine learning model in predicting employee-persistent work-life balance. Second is to identify the important features affecting employee-persistent work-life balance. And finally, is to provide recommendations that support HR strategy to enhance employee satisfaction and retention using predictive analytics. And next one, the dataset has 19 features such as stress level, working hour, and company support. And the dataset was undergo data pre-processing step to convert the data into more suitable format for prediction model. Firstly, missing values was handled, where mental health condition is replaced with none and physical health condition is replaced with both. Next, employee ID is removed as it's not a necessary data. The third step is to detect outlier, but in this study, no outlier was found. Next, categorical data was encoded using both ordinal and one-hot encoding. In step 5, continuous features were scaled using the feature scaling. Next on, features importance was applied to identify the key features, and features like age, work hour per week was identified as the important feature that should be prioritized. In the following step, the data will be split where 75% of the data is allocated for training and 25% for testing. The target work-life balance rating is transformed into binary classification, where ratings above 4 are categorized as high work-life balance and labeled as 1, and ratings of 4 or below are classified as low work-life balance and labeled as 0. After splitting, SMOT was used to handle class imbalance issue. In the final step, scaling was reapplied again to ensure the consistency after SMOT. There are 5 steps to evaluate the machine learning model, and in this section we'll focus more on model building, while the model evaluation will be presented in the following slide. There are 6 models will be trained using Python, and all models will fit on the training dataset and evaluate using the test set to assess their predictive performance. So this table shows the overall performance result of all 6 machine learning models. Each model was evaluated using the 5 key performance metrics, which are accuracy, precision, recall, F1 score, and RC/IUC. Based on the table, the gradient boosting classifier achieved the highest accuracy of 80.32%, followed closely by random forest at 79.60%. KNN reached the moderate accuracy of 72%, while logistic regression came slightly lower at 69.52%. In overall, all models performed below 81%, and this indicates that there is a significant challenge in correctly identifying the minority class, which is the employee with poor work-life balance. Next, in the precision score, for all models show very low score, which ranging from 0.08 to 0.38. Same as accuracy, the gradient boosting classifier achieved the highest precision score of 0.38. This behavior reflects what Efferent emphasized, the class imbalance through the model toward the majority class, which lead to low precision. Next, the recall score for all models also show very low score, ranging from 0 to 0.196. This shows the difficulty in incorrectly identify employee with minority class. Next, the F1 score also remained low across all 6 models. The decision tree performed the best among all 6 models at 0.21. Yu and Chen explained that the traditional machine learning model tend to focus on optimizing overall performance metrics and lead to bias toward the majority class, causing the low F1 score. And lastly, the highest of RC AUC score is 0.5, which achieved by random forest classifier and gradient boosting classifiers. This result indicates a moderate ability to differentiate between the positive and negative class. More parties have explained that the dilemma of imbalance can have adverse effect on the performance measure such as the ROC. There are some studies how to explain that why performance was so poor. Handami suggests that the work-life balance measurement vary across individual and culture, make it hard for model consistency. And Efferent explained that imbalanced data can lead to bias to machine learning model. And already showed that SMOT have limitation might have create overlapping synthetic data which can hurt the performance. Despite overall poor performance, gradient boosting classifier is still considered the champion model as it achieved the highest accuracy of 80.32% and precision score of 0.38. So it considered the most balanced performance among all the machine learning algorithms. So in conclusion, predicting persistent work-life balance using machine learning is possible, but limited by data and construct complexity. The gradient boosting classifier performed the best, but all models struggle to detect employees with poor work-life balance. So for the future work should focus more on gathering better data, improve sampling method, and model interpretability. There are some limitations found in this study. First, class imbalance has heavily skewed prediction. Second, the dataset heavily rely on subjective, self-reported values such as stress, satisfaction, and this may reduce the reliability. And third, there was lack of longitudinal data to track employee changes over time, limited the depth of this research. So, to overcome the limitation faced in this study, there are several recommendations that can be suggested for future research. For example, advanced resampling techniques such as SMOT-ENN and explainable AI methods such as LME to resolve the imbalanced class issue. Also, future data collection should include more objective behavior indicators such as action record to enhance the reliability of dataset. Lastly, future research should include more features that could reflect the real work-life experience. So that's all for my presentation. Thank you for listening.